let's continue our journey in analytic geometry with the circle. Okay, and among the few things that we're going to focus on in this video in respect to the circle is first of all, we'd love to talk about conic sections. Like, we'd want to understand what conic sections are. When someone says conic section, what are you able to understand just from the two words conic section? What comes in your head when you hear that? And of course, we'll look at the definition of the circle and also look at the equations of the circle. And when I mean equations of the circle, this is when like equations of the circle, I'm trying to refer to the standard equation and the general equation of the circle. So we'll try to see the difference between the two, and we'll also try to look at few angles that have to do with the circle, and of course they will be coming up as we go on. Okay, so now looking at conic sections, um, what is really a conic section? What do we mean when we say conic section? So one thing that we have to understand is that when you have a plane, okay, when you have a plane uh, that intersects a double napped cone, okay, that intersects a double napped cone. So the intersection between the plane and the double napped cone is what produces the what conic section. So that intersection, uh, it it's in different ways. So each type of intersection like produces a certain kind of conic section. It's either it's a circle, maybe it's an ellipse, or it's a parabola, or it's a hyperbola. So we get conic sections from the intersection between a plane and a double napped cone. Okay, so now what do we mean by a double napped cone? Okay, so here's the thing. uh, you can have something like this. Okay, you can have something like that. Okay, can do better. Can be something like that. Okay, then on the middle we are going to have our axis. Okay, we're going to have our axis on the middle there. So this is at a 90 degrees angle like that. The same applies to the bottom part. Okay, so now what are the parts of this double napped cone? So what we mean by double napped cone is just it's more like you have two cones. One is put upside down, the other one is facing upwards. Then it's like they meet at this point, like that center there, and that center that we have right there is what is called the vertex. Okay, that is what is called the vertex. Then at this point you're going to have the what? You're going to have the vertex angle there. Okay, out of the vertex angle, then this line is what is called the axis. Okay, then of course this one is the upper nap, this one is the lower nap, and what else do we have? um, okay, this line here, okay, is what is called the directrix. Okay, we understand these terms better when we start talking about conic sections such as the ellipse, the parabola, so on and so forth. Then this is the generator. Okay, so this is what generates. This is what this line is what rotates so as to give us the what um, those double napped cones. So that's the generator there. Okay, so now when we say the intersection between the plane and a double napped cone is what produces conic sections, then in respect to the circle, what type of intersection do we talk about? Okay, so and one thing that you have to focus your attention on is the fact that as the plane intersects the double napped cone, it also intersects the what? The axis. Okay, this axis, the line that is on the center, this one. Okay, so the uh, when you are getting a certain type of conic section, uh, what determines what type of conic section you get? It all depends on the angle between the plane and the axis. Okay, so now before I go to that, let me briefly talk about the circle, so that after we define the circle, we'll see how it's related to that double napped cone there. Okay, so the simplest definition that you can have or that you can use for the circle is just that it's a set of points that are at a distance from a fixed point called the center, and that distance is called radius. Okay, so just talking about a set of points. Okay, a set of, let me say, all points. Okay, set of all points that are at a distance from a fixed point, from a fixed point called center. Okay, and that distance that we talk about, this distance is called radius. It's indicated using r. It's called the radius. Okay, another definition that you'd give that would make a lot of sense when it comes to the intersection between a plane and a double napped cone is the fact that a circle is a conic section formed when the plane is perpendicular to the cone axis. So if you have a plane like that, okay, let me say something like that. So now let's say this plane that we have, this is a plane. Okay, this way this plane is at a 90 degrees angle, like intersects the uh, it meets the axis at a 90 degrees angle. What you're going to have is a circle. You're going to have something of this kind. Okay, you're going to have something of that kind that is going to be a circle. It depends on the view, that depends on where you are viewing it, but otherwise, as long as the plane is at a 90 degrees angle with the axis, then what you're going to have is what is a circle. So that's why we say conic section formed when the plane is perpendicular. Being perpendicular meaning is at a 90 degrees angle. Okay, so that's how we get a circle from a double napped cone and the plane when they intersect. Okay, that is when it's at a 90 degrees angle. Okay, so that's basically the definition of the circle. Then what are we able to get from the what are the so we have covered the conic section and the definition. Then what are the equations of the circle? Okay, so now maybe let me try to draw a circle, and so that we'll try to use the same. Okay, is it too big? Yeah, it is too big. Okay, something like that. So we have our center at this point, that point there, that's where we have our center. Then let me just try to put up some lines so that we'll try to uh, reason from there as we get the equations. Okay, all right, something like that. The other one seems to be bent. Okay, so we have our center at this point right here. Okay, so this is basically the circle. We were saying a circle is a set of points that are at a distance from a fixed point called the center. So this point here that we have is called the center. Okay, so here you have the radius, you have the radius, you have the radius, you have the radius there. So this is just a point. This is just a point. It's just a point. It's just a point there. If you want, you can have multiple points. I mean, you can have multiple distances giving you the same, giving you a point whose distance is still the same, is still called the radius. Okay, so now the equations of the circle, you have a standard equation and the general equation. So let's look at first of all the standard equation of the circle. So in terms of the standard equation of the circle, the standard equation of the circle is written in the form x squared plus y squared is equals to what? Is equals to r squared. You might see this being written as x, I mean x minus h, you put squared there, okay, plus y minus k squared is equals to r squared. So these two are the standard equations of the circle. Then how are these two different? This one is when the circle is centered at the origin. What do I mean by the origin? When talking about the origin is that as we sketch these conic sections, we are going to be sketching them on the xy plane. Okay, we're going to be sketching them on the xy plane. So when you have a situation where, like here, we know this is our y-axis and this is our x-axis. If our circle is centered at the origin, meaning at 0 comma 0, okay, this is what you're going to use as the equation of what? As the equation of the circle. Then if your circle is centered at some any other point besides this, besides the origin, this is what you're going to use. But I would also advise you to put this one more in your head, simply because if your circle is centered at the origin, your h is going to be 0 and your k is going to be 0, hence it will still give you what? Give you that one. So if I have this one in my head, if I have this one in my head, I can never go wrong, because I can use it when the circle is centered at the origin, and I can also use it when the circle is centered at some other point but the origin. Okay, so those two are the standard equations of the circle. Now let's look at the general equation of the circle. The general equation of the circle can be written in the form x squared plus y squared plus dx plus ey plus f is equals to 0. This is the general equation of the circle. What's the difference between these two? Okay, so from the general equation of the circle, you can get your standard equation of the circle, and from the standard equation you can also reverse it and get the general equation. There are times when you're given points. Okay, there are times when you're given points. Let's say they give you 3 points, then they ask you to use those points and determine the equation of the circle. This is what you're going to use. You're going to use those points, you're going to get them, use the general formula, and it will give you the what? It will give you like the ideal general formula. That is the general formula without these without the d, e and f. What do I mean? That is a situation whereby you have now found what your d is, what your e is, what your f is. Then use that general equation to find the standard equation. How do you get it? It's very simple. You just complete a square and you come up with a standard equation. It will give you the value of r, and it also give you the value of h and the value of k. That is if the circle is centered at another point but the origin. Okay, so that part is very, very important, and I believe you're going to understand that better as we do a few questions. Okay, so that will be all in this video. In the next video, we're going to talk about we'll look at some few questions, so that we try to see if we have really understood everything that we have talked about here. We have talked about the definition, we have talked about the equations, and of course we have talked about the conic sections in general. What must come in your mind when you hear the word, when you hear conic sections? Like, it's very simple. We just get a plane, a double napped cone, intersect them. The angle that you get, that is the angle of intersection between the plane and the axis, is what tells you what type of conic section you're dealing with. If the angle is perpendicular, it's very simple, that is a circle. If it's maybe the angle is, I don't want to use values right now, but whether it's an ellipse or a parabola or hyperbola, we'll be able to understand that in other videos as we focus on those other conic sections. So that will be all in this video. Thank you very much for watching.